Exercise on polar form of complex number. In this tutorial, we are going to discuss the product and quotient of two complex number, which is of course in polar form. So I highly encourage you to pause the video and try the following questions. Z1 twice of 2 times cosine of pi over 4 plus I sine pi over 4, and Z2 3 into cosine of pi over 3 plus I sine pi over 3. So determine Z1 times Z2, Z1 divided by Z2, and 1 over Z1. Just pause the video and try. Let's start from the first one, the product. Z1 times Z2, Z1 times Z2, which means that is the same as twice of cosine of pi over 4 plus I sine pi over 4 times 3 into cosine of pi over 3 plus I sine pi over 3. From the product of two complex number, which is in the polar form, will be the product of the modulus, which is 2 times 3. Okay, 2 times 3, consider this as multiplication. Okay, and the sum of the argument of the two complex number. So that is the same as cosine of pi over 4 plus pi over 3 plus I into sine pi over 4 plus pi over 3. So this is equals to 6 into cosine of, there you have 12, 3, 7 over 12 pi plus I sine into 7 over 12 pi. This is it. So the other one is division of complex number. Okay, the quotient of two complex number will be in the polar form, especially is the product of the quotient or the division of Z1 and Z2, the modulus, and the difference of the argument, or the difference of the argument will be in terms of the angle. So this is the same as 2 over 3, okay, into cosine of pi over 4 minus pi over 3 plus I sine pi over 4 minus pi over 3. Okay, this is 2/3 of cosine of, when you work on this one, you will have minus pi over 12, okay, plus I sine minus pi over 12. Or you can rewrite this as, since cosine is even function, this is the same as 2/3 of cosine of pi over 12, or you can even leave as it is, minus, because sine is odd function, I into sine pi over 12. Okay, let's move on to the third one, 1 over Z1. 1 over Z1. Okay, how are we going to solve this one? 1 is the same as 1 plus 0i over Z1. So let's first write this. Let's first write this in the form of polar form. Therefore, this is the same as 1 units along the positive x-axis, the positive real axis, and 0 units along the positive y-axis, our imaginary axis. So it lies on the x-axis. So the angle is obviously 0 degree, or our argand, our argand is 0 degree, argand of z, argand of, this is z naught. Okay, z naught will be 0. Or you can even say argand of z naught is equals to tan inverse of y over x. This is the same as tan inverse of y is 0 while x is 1. So the only angle that the angle that gives you in this case is 0 degree. This argand. Therefore, let's find r, which is the distance from the origin to that particular complex number. Of course, in this case already is 1 squared plus 0 squared, so which is 1. So our polar form of that complex number z0 will be 1 into cosine of 0, okay, 0 plus I sine 0, okay, I sine 0. Okay, so let's move on. As you know, the quotient of two complex number, especially in the polar form, will be the quotient of the modulus and the difference of the argand or the argument. So this is the same as 1 over z, 1 is the same as, or in this case z not, is the same as 1 over the modulus. Okay, let's find the modulus of z naught is 1, and the modulus of z1 is it's already here 2. Okay, 2 into cosine of z1 is 0. Okay, 0 minus z2 is the modulus of z1 is here pi over 4. Okay, pi over 4 minus, or I sine 0 minus pi over 4. Okay, this is the same as 1 over 2 cosine of negative pi over 4, okay, plus I sine negative pi over 4. You can write this as it is, or if you want to, you can express this as 1 over 2 cosine is even function cosine of pi over 4 minus I sine pi over 4. So both could be the answer.